How to get precise tolerances for robot parts prototyping. Imagine building a robot where every part fits perfectly without gaps or looseness. That's what precise tolerances help you achieve. When working on robot prototypes, getting the dimensions just right is key to making sure everything works smoothly. But how do you make sure your parts are within those tight limits? Let's walk through the facts that can help you get the exact tolerances you need for your robot projects. First, understand that different manufacturing methods have different standard tolerances. For example, CNC machining, which uses computer-controlled cutting tools, can typically produce parts with tolerances around plus or minus 0.5 inches, or about 0.13 millimeters. If you need even tighter tolerances, precision CNC machining can achieve plus or minus 0.2 inches, or roughly 0.51 millimeters, especially on features like drilled holes. But keep in mind, tighter tolerances often mean higher costs and longer lead times. Be sure to clearly specify your critical dimensions when talking to your manufacturer so they understand exactly what you need. Next, consider 3D printing. It is great for quick prototypes and complex shapes but generally offers less precision. Most standard 3D printers can produce parts with tolerances around plus or minus 0.10 inches or 0.25 millimeters. Some advanced 3D printing techniques, like stereolithography or selective laser sintering, can improve accuracy but still usually don't match CNC tolerances. You might need to do post-processing, like sanding or drilling, to fine-tune the dimensions. Injection molding is another option, especially for plastic parts. It can produce very consistent parts with tolerances close to plus or minus 0.5 inches or 0.125 millimeters once the mold is made. However, creating the mold is expensive and takes time, so it's better suited for designs that are already finalized. Vacuum casting is useful for small runs of plastic parts. It offers good surface finishes and tolerances around plus or minus 0.5 inches, making it a solid choice once your design is stable. To get the best results, always specify which dimensions are critical on your CAD drawings. Mark these clearly and provide realistic tolerance values based on your chosen manufacturing process. Avoid overly tight tolerances unless absolutely necessary, as they can increase costs and delays. When selecting a process, match your tolerance needs with what each method can reliably produce. CNC for tightest fits, 3D printing for rapid testing, and molding or casting for larger quantities with consistent quality. Material choice also plays a role. Metals tend to hold tighter tolerances because they shrink less and are less prone to deformation during manufacturing. Plastics may shrink or warp more, so discuss your material options with your manufacturer to understand how they impact the tolerances. Design features matter too. Parts with features on the same side or simple geometries are easier to hold within tight tolerances. Complex shapes might need design adjustments to make manufacturing easier and more accurate. Always communicate your tolerance requirements early in the process. Many manufacturers offer design for manufacturing reviews, which can help you optimize your design for better accuracy and lower costs. And finally, use proper inspection tools like coordinate measuring machines or optical comparators to verify your parts meet the specifications during prototyping. Balancing precision, cost, and time is essential in robotics prototyping. CNC machining provides the best accuracy for functional parts, while additive manufacturing speeds up the process for initial testing. Molding and casting are great for plastic parts once your design is set. Clear communication and understanding manufacturing limits will help you produce robot parts that fit perfectly and work reliably.